with the presence of some directors of Tecnicelpa here, so they can bring this message. It's always a pleasure to be here and to help. So we have a very interesting session here with 3 presentations that I think will be very interesting. And I will start to present the first one that is brought by Marcio Teixeira Oliveira, which holds a PhD in information science from Fernando Pessoa in Brazil. Oh, sorry, here. Sorry. Oh, you studied here. Sorry. Okay. And also has a degree by Brazil University. So he is an undergraduate of computer science from Universidade Paulista, no Brazil, and completed a postgraduate specialization in component engineering with Java. So he will be presenting us the use of information system in the management of general shutdowns in the pulp industries.
And now I'm going to present the use of information system in the management of general shutdown in the pulp industry. Introduction. General shutdown. What is general shutdown? In Portuguese, parada geral. In the pulp and paper industry, a general shutdown refers to the complete stoppage of all machines and the process unit for inspection, to ensure equipment safety, compliance, and confiability, maintenance, to execute preventive or corrective actions, include clean repairs and part replacements. Why the general shutdown? In Brazil, there is an employee protection regulation called NR 13, in Portuguese, Norma Regulamentadora 13, NR 13. Generally in Eldorado Brazil industry, every 18 months, the factory must undergo inspection and maintenance to comply with NR 13. In general shutdown, there are many reports. The most important reports are inspection report, no conformity report, repair report. An inspection report is a technical document prepared after inspection, conducted during a scheduled shutdown of the pulp mill. No conformity report. The no conformity report is a technical and administrative document prepared when, during a general shutdown, a fail, deviation, or no compliance is identified in relation to established standards of safety, quality, maintenance, or regulatory requirements. Repair report. The repair report is a document that formally records the correct or preventive maintenance interventions performed on industrial plants equipment and system, usually following inspection or as a result of detected non-conformity. Successful case, Eldorado Brazil industry. Since 2010, Eldorado Brazil has been one of the largest pulp producers in Brazil, with annual productions of 1.8 million tons. The system was tested at the recovery boiler shutdown event. This is an overview of Eldorado Brazil industry and the machine choice recovery boiler. Information system, TAG registration. TAG, the same identification of machine. The system allows equipment to be registered using TAGs. There are two options for TID registration in the system. A unique tag. For example, this picture continuous discharge tank with one tag and no parts. A unique TID with multiple parts. This is a recovery baller with many parts control. Special report. The digital control of the special report has three stages: gray, green, and yellow, represented through a traffic light system. Not started, gray. In progress. And released. So, special report 3 stages. Until 3 stages. No conformity report. The digital control of no conformity report has one stage, red, represented through a traffic light system. No conformity report. The red traffic lights. Repair report. The digital control of repair report has one stage, green, represented through a traffic light system. Released. Repair this picture. Repair report change no conformity report. The red to green. Under construction, the component statistic control under recovery baller. In construction. Our options. Send an email after saving the report in the system in real time with information such as register special report, repair report, no conformity report. Monitor reports in real time through the dashboard. Use access control. Store reports in the private cloud. System improvements, three-dimensional data views, example digester screw. The first step is to register information, building, cracking, corrosion, and other. After that, it's possible to view the data in three-dimensional mode. In a general SHUTDOWN, it's possible to register data in the non-conformity report. Apply fail modes such as building, cracking, corrosion, and others. Display of the complete record history. Real-time operation panel. Three-dimensional equipment visualization for defect mapping. This is a digester screw. This week happened in the general SHUTDOWN in Eldorado, Brazil industry. And this piece, the change in the general SHUTDOWN. In digital, there is a digester screw with mask red represented corrosion. Conclusion. The digital of inspection, non-conformity, and repair reports has proven highly useful for information managing during the general SHUTDOWN. Moreover, the system has enabled real-time monitoring of inspection and maintenance activities, contributing to more effective decisions making by managers. The three-dimensional visualization proved to be effective in provided a detailed representation of equipment fail, contributing to the analysis of condition in the planning or corrective actions. Thank you.
Thank you, Marcio. Thank you for your presentation. I think the subject is a very important subject. We all experience, for sure, or most of us in the room experienced general shutdowns, and we know how hard it is to have all the teams that are working on a general shutdown knowledge about what's going on and what is already inspected or not. So I think it's an important contribution. I'm sure in the end of the session, when all the three presentations are ended, we will have some cues, some questions for you regarding this. So we move to the second presentation, which will be a very interesting one also, and a very interesting subject nowadays, more and more, which is the autonomous mill, in this case the pulp mill. And to present the digitalization and human-centric change as drivers of industrial excellence is André Demuner, who works as a developer in industrial automation and digitalization solutions on a global scale. He has built his experience through projects in Europe, Asia, and Americas, with a strong focus on pulp and paper sector, as well as mining and energy. He played a key role in initiatives involving advanced process control, artificial intelligence, and industrial digital platforms. Currently heads the digital portfolio at Andritz, with a focus on innovation and global strategy. Welcome, André. The floor is yours.
Thank you, Tecnicelpa, and all of you for being here. It's a pleasure again. So, 15 minutes to talk about an important topic. I will do my best to cover what Andritz has been doing over the world with this important topic. Let's get started. Okay, first of all, it's a message from our CEO, Dr. Joachim Schumbeck. Andritz's aim is to make the fully autonomous mill a reality. Everything that we are building currently has this as a main step. Every solution, every application, every functionality, we have this main target. And to talk about this autonomy, we are talking all the time about some important pillars that we cannot miss. We are talking about autonomous control. We cannot talk about autonomy without talking about less operator intervention, focus human oversight, or process optimization, or remote operation, or even reliable operation. Makes no sense to develop or deliver to the market some functionalities if at the end of the day, this will not address any of these topics. So, main pillars for our development in terms of solution and functionality for the digital applications: process, assets, and human. Process, because we are technology providers, we have expertise in process, in assets. So we are embedding more and more this expertise into the products in a way that humans, operators, the personas in the plant will use these applications in a daily basis in a more easy way, in a way that these tools are part of the daily routines. So these main three pillars are part of the process, let's say all the time during the development phase. So what we have been doing over the years, we have more than 70, 80 agreements for digitalization, including APCs over the world, only for optimization, and several agreements with maintenance and all this stuff. What we have been doing for the last 10 years, we mapped all the operator journey in a plant. So it means that the operator has to deal with start and stop sequence, continuous production, prevent upset, not only control the plant, but prevent that upset to happen. Manage the upset. The deviation occurred, and now, what should they do? All of these are tasks for the operator, and also supervision and reporting. Imagine in a daily basis with all these tasks, the time that the operator or any other persona will have to dedicate that time for some study or for some deeper troubleshooting. How can Andritz or these digital solutions support the personas? We have been building solutions for all these stages with one single purpose: support the personas, not to deliver functionalities. Support the operator to start and stop a plant. So we have some smart sequences that we call, that is start and stop an entire plant in a couple of minutes, automating all these steps that the operator typically do. But okay, but the DCS can handle that. There are several functionalities here that work in a better way than the DCS to deal with some anomalies in the middle of the way, to change the direction, and all these deviations that an intelligent system must do. Also, a lot of solutions for continuous production, how to track this productivity in the plant, how to track OE, how to track performance and availability. There are several applications on that as well. Prevent upset. We have been developing solutions for asset health to track mill shutdown, to track deviations in control valves, motors. Here it's just to exemplify to you that all these decision-making that have been doing in a plant, it could be in milliseconds or even seconds for the operator, or imagine a production manager that needed to take some actions in minutes to hours to change a recipe in the plant, or to change a production grade, or even to make a decision to stop the plant or to increase the production, or even a mill manager in a daily basis decision-making to work in terms of budget control. All these solutions that we are going to see later on will address somehow to make sure that these personas in the plant will have less interaction with this manual work. We have been working this concept. This has been applied already in some mills. Latest example is Cerrado plant, which is in this stage here. That's our latest project that we sold with this stage of autonomy. It goes from 0 level to 5, where 5 means full automation, but it does not mean at all no operator. It means that the operator in the level 5 is still engaged with the process, but the automation and the intelligence in the plant will take some actions for them, but the operator remains engaged. We did some research in the market where we confirm that the operator, being the main player in the production daily routine, is the most effective solution for controlling a plant. And if you see here, all the solutions that we have been developing address also solutions in each stage. It means that to reach certain level of autonomy, you don't need all at once. You can progress step by step. That's what we have been doing with the customers. If in an existing mill, we can implement single steps of solutions that will address benefits, and then in the future, we can achieve certain level of autonomy. Or if it's a mill that is born from the base, like a greenfield project, like this Suzano Cerrado in Brazil last year, this is born already with some technologies. All these enriched technologies, later on, this will be provided to you. You can cross-check that. On that side, there is some concept about these levels. But here on the right side, you see how our applications address each stage. Stage 0, where there is no autonomy, you can at least have, for instance, some PIMS, Plant Information Management System, to track the process. Or level 4, for instance, the automation is capable of performing all control actions. We have one anomaly detection with a digital twin and the system acting in the process. It means that now the APC will have some support from other solutions. That's how these solutions works in a combination. All of these solutions in each step of autonomy are included here. This is our digital solution portfolio. From compact to large systems, it means that we can address through a single tissue machine or a large pulp mill or a small board machine also. And this goes from a regulatory control with a Matrix X system, which is our DCS, to a mill-wide optimization, where we control all the plant, all the balances and inventories. But here is more to tell you that it's hard to say that to achieve a certain level of autonomy, need all these solutions. But the most important thing, as I mentioned, is to progress in this journey. How to make sure that in the stage 1, we have people engaged using these tools. Because it's easy to add all these solutions in a greenfield project, but when the mill starts, all the production running, how the people will deal with all these solutions? That's what we are proposing to the customer, a journey where we start from the basis and we can progress to achieve certain levels of autonomy. But here is just to mention that we are covering basically all this journey, operator training, digital twins. Now we are official Aveva partnershippers. We integrate this Aveva PI systems as well. There are some agreements for APCs like OPP, different kind of business that we are doing to achieve these autonomous operations. One important thing is interoperability. As I mentioned, this partnership not only with Aviva, but also Microsoft. We integrate Aviva system from 3 or 4 months ago, and also 100% Aviva system, or also in combination with our Matrix platform. So it means that we understood that Aviva has the market share in pins. So it's nice to be with Aviva because we do not intend to replace Aviva, for instance, but we can make sure that you can achieve certain levels of autonomy, adding new functionalities that maybe the Aviva will not contain. We can support you to make this integration and make things even more powerful. But interoperability is a must. We are not interested to deliver functionalities. To achieve a certain level of economy in the process or increase performance, we need to cooperate with the other systems. What else? This is a display where we connect many functionalities in the plant, and it has a system to detect, as I mentioned, deviations in valves, in motors, in pumps, or even one APC. But all of these systems are providing some useful information. And let's say the instrument technician is there in their room, checking some displays. Another mechanical technician is checking another display. Each one, for each discipline, is checking their own information. But here we are consolidating. What are the main information for decision makers, for mill managers? In terms of quality deviation, some prediction, some anomaly that will pop up and require some immediate action. This is the screen that we are working. This is the display where we'll prevent some defects to happen. And the mill manager will be informed on time. That's the kind of display where we consolidate all this information. This digital twin, we have been working, we have already some examples of that, some use case, where we model the entire plant with physical characteristics. It means the elevation, pumps, curve, valve curve, tubes, all the equations, we model that, and we have been connecting that since years ago to the real plant. What's the outcome? You have your current plant scenario and also the future one. You can play with this model, making forecasts, what-if scenarios. What if increase my digested in 20% production? What will happen? We have everything modeled. We have the output. What else? That's one example where it's not a concept. We have that applied already. And that's one example for recovery boiler where the digital twin provides some indicators such as boiler efficiency, some heat rate. The digital twin is handling, in this case, some complex variables. APC works very well with dead time compensator, multivariable process control, but there are some variables such as weather conditions in 1 year that the APC does not handle well. And the digital twin in this case make forecast for supporting the APC in most effective decisions. Let's forget that conditions where the APC is turned on and off. The main idea of the digital twin connected to the APC is to support in these scenarios where the APC is not able to handle. One real example for causticizing area, one part of this PULP process, where anyone in the plant can check the actual condition of the causticizing area, right here, and also cross-check what is the optimal point. Am I handling the plant well or not? You can easily check that. The model is behind the scenes here, running all the time. But we don't care about the models. What is the outcome for that? Am I running the plant in an optimal way or not? You can check this kind of deviation or information. What else? This copilot, we presented last time in Tecnicelpa. We are progressing a lot with that. we developed an agent named the Matrix and the Android's Copilot. It's based on ChatGPT. It's a virtual assistant. It will collect all your documentation, train, and give you some insights for troubleshooting, for safety and maintenance instructions. But you don't need to use Matrix or Android's software to use this Copilot. If you are a Microsoft customer, you can go to the marketplace and there will be an agent, one expert in pulp and paper to add to your ChatGPT. It means that the Android has built this agent, which is the expert in pulp and paper. We have trained that a lot in a way that you don't need, for instance, to give context for a Copilot. The context, we are working and tested that for you. But on top of that, we add your documentation in your environment to make sure that these virtual assistants will be based on your process, not on generic process. Just to go quickly, at the end of the day, make some analogy with Formula One. We have operator, maintenance teams, maintenance engineers and data scientists, mill manager. Makes no sense to run all these applications and go towards autonomy if we do not have some change management. The problems, the issues might happen. We should identify that. We should address that, and we should solve the problems. The solutions that we have been developing, somehow they are interconnected to support people, the personas in the plant, to make sure that we connect that. Okay, a problem is popping up here. Then how we track that? Is there any maintenance order or not for that? So all the solutions track this process to make sure that the change management will not be forgotten here. Just to give you two examples, one for one existing mill, we increased the 18% production capacity in Eldorado, and also we achieved the 95% mill availability with lots of digital solutions there. And second one, oldest record, typically in the past, an Android plant used to achieve the nominal capacity in 6 months. Last year, we achieved a production 100% nominal capacity in 7 days, with all these solutions included. Sorry for the time, but that's the presentation for today. We can go deeper later on or in any other situation. Thank you.
Thank you, André. Very, very interesting presentation. I'm guessing there's a lot of questions on the room. At least I have a few, so I think we will use the 15 minutes for sure. So we'll go to the final presentation by Mr. Hannu Hämäläinen. I'm sorry if the pronunciation is not the best one, but and it will be focused on artificial intelligence optimization for material savings that, of course, contribute for sustainability and profitability in the pulp industry. So Mr. Hämäläinen is the founder and president of Tecnicelpa, a company that a lot of us know well. And that makes process optimization technology for our sector, and not all for our sector, but for others. Okay. So since he started his business for more than 30 years now, Tecnicelpa has been able to create customer relationships in all continents with hundreds of technology deliveries. And of course, it has machine vision based solutions to improve raw material and energy efficiency, like I said before. So the floor is yours. 15 minutes for your presentation. Thank you.
Dear guests of Tecnicelpa, as introduced, I'm Hannu Hämäläinen, president of Tecnicelpa, a Finnish company specializing in production flow optimization for the pulp industry. Artificial intelligence has influenced our work, daily work, especially in research and development over 15 years. Today I will show you how AI can deliver remarkable savings in both profitability and sustainability for pulp mills. When we look at the pulp industry from a market perspective, we all recognize the key challenges of today's business environment: rising raw material prices and limited sources of sustainable wood increase the importance of supply chain performance. Mills want more precise data on incoming wood to avoid overpaying. Manual measurements often lack accuracy and quality insights. In some factory studies, mills have paid up to 10% more than the actual value of the material. Wood loss during debarking also needs to be minimized. Environmental requirements affect the industry not only through raw material sourcing, but also through emissions and supply chain sustainability. Reducing raw material usage also lowers the need for chemicals and energy. Retirement and high labor costs challenge operations. Mills are seeking more automated solutions to run efficiently with fewer staff. Summa summarum, raw wood is expensive and environmental demands are increasing. Savings in procurement and debarking are essential for profitable pulp production. Tecnosavo has been working on solution to these problems for decades. Our technologies reduce wood, energy and environmental impact by up to 10%, and at the same time production yield increases by around 4% per ton of purchased raw material. I want to emphasize that these numbers are very much mill specific. We are confident that pulp quality also improves combined with higher yield and production capacity. This enables mills to achieve premium pricing and greater profitability. Tecnosavo has a strong background in optimization solutions for the pulp industry. Over the past 35 years, including more than 15 years with AI-based systems, we have delivered hundreds of solutions to dozens of countries. As a Finnish company, we follow the highest standard and best practices in wood handling. And just to mention this Brazilian case, it will be pulp mill in the state of Mato Grosso do Sul, Brazil. This mill will be the world's largest single-phase pulp mill project with 3.5 million ton annual capacity. When completed, it will use the most artificial intelligence in the world. Our technology goes to wood and chip handling areas in this mill. Let's take a closer look at our solutions from gate to digester. Tecnosavo supports customers in incoming wood measurement, woodyard operations, debarking and chipping, chip quality surveillance. We use various sensor technologies to collect data for AI-based analysis. Our intelligent systems respond systematically to events on the line, operating according to factories' defined parameters. This transition from manual analog control to AI-driven automation eliminates human error and shift-based inconsistencies. It also reduces production downtime and improves occupational safety. Line work shifts to control room operations. Wood loss in debarking decreases and chip quality becomes more consistent before the digester. Entering the digester. As mentioned, accurate data and automation in optimization save significant costs, and they also enhance sustainability. When a mill uses 10% less wood, chemicals, and energy, emissions drop accordingly. These savings apply not only on-site operations, but also upstream where 10% less material is transported to the mill. It all starts with transparent data collection and AI-based optimization. The benefits extend to procurement processes, vendor classification, woodyard organization, and ultimately to higher quality pulp production. AI-optimized solutions ensure optimal raw material flow, efficient debarking, and a balanced chip stream to the digester. In the automated raw wood measurement process, the system collects accurate data on incoming wood and wood room inventory. This data helps the procurement department rank vendors based on wood quality and pay the correct price for each wood delivery. It also supports production planning by grouping similar wood batches together, speeding up the processes to end and ensuring consistent production quality. Automated debarking also shifts personnel from physical demanding line work to safer control room monitoring. There are no shift-based differences in quality, and the system operates 24/7. After debarking, the wood is chipped. The condition of chipper knives directly affects chip quality. Stones and poor quality wood can damage knives. Most mills change knives based on volume or operating hours, which can lead to unnecessary cost and poor chip quality. Low bark content improves pulp quality and reduces the need for production time. Used energy and chemicals in the cooking process. AI ensures balanced, high-quality chip flow to the digester, optimizing consumption across multiple production factors. Tecnicelpa's chip surveillance solutions are designed for continuous chip flow monitoring and automated lab sampling. When optimizing pulp industry processes, it's important to remember that wood is not a standard raw material. Most industrial processes rely on tightly defined particle parameters, but every log of wood is unique. Its dimensions and internal structure vary depending on growth conditions. Moisture level, particle size, wood content, length, thickness, and weight all differ. Here you can see the daily variation in incoming wood. Even cutting edges vary, making manual measurement difficult and time-consuming. AI-based measurement collects accurate data for wood bookkeeping in under a minute, enabling a transparent and fully automated process. Here you can see a machine vision image from our AI-based measurement system. Each patch is captured as a 3D image and reported with detailed dimensions to the factory's wood bookkeeping and procurement system. Each incoming batch receives an individual report including loose and solid, log volume in cubic meters, log length and diameters, wood species, bark content. Procurement can base payments on the actual mass of incoming wood and rank vendors by their ability to optimize deliveries according to mill-specific instructions. This data also support vendors in their own quality management, helping everyone improve wood flow from forest to factory. The precision of AI-based solutions becomes clear when we see how the system can recognize fiber direction and chip quality and use that data to guide chip flow to the digester. This level of performance is impossible with the traditional methods. What does AI-based optimization means in terms of money, especially in the debugging stage? It means millions of euros. Take this example, a 24% reduction in wood loss with a volume of 1.5 million cubic meter results in over 2.5 million euro in raw material savings. Highest savings what we have received are close 6% when wood loss decreased from 9% level to 2 to 3%. In various cases, we can observe a 30% reduction in drum energy consumption and at the same time 20% increase in capacity. My personal vision is that the AI-based optimization will become a standard in pulp production within few years. The business environment demands companies optimize raw material usage and production efficiency to meet financial and ESG goals. We are talking about very much artificial intelligence, but it does not give a rosy future necessarily. Here is researched facts that 99% of us don't understand 99.9% of the technologies around us. Here is AI, a lot of, but I don't know what kind of it is, and so I belong to this majority. But that's what it is today. To summarize, I hope you will remember the benefits of AI are based on collected data. The process starts at the mill gate. Data drives transparency and optimized raw material usage, leading to higher profitability and sustainability. AI guarantees precise information, faster operations, reduced manual labor, improved safety, lower costs, and reduced environmental impact, alongside increased revenue. The technology is proven and ready. The time to act is now. Thank you all for attending the event. I hope to hear from you soon.
Thank you, Mr. Hannu. So we have around 10 minutes for questions. I have here some, but I would give privilege to the audience questions first. So who wants to start?
Question at the same time.
Yeah. So I will start, no problem. So André, first for you, because I think we are all very curious about this autonomous mill, and you have a lot of ideas and conceptions, maybe wrong, some of them, but I guess we can all say that we are closer and closer to this kind of a dream that a mill can be can work almost alone. Two practical questions. One, in Cerrado, what do you think is the fundamental difference on the organization of the mill, because it's very autonomous, compared with a traditional mill that don't have this degree of autonomy?
Well, when we talk about such a greenfield project, it's starting the base with this concept. From my perspective, from my understanding, over the years in Suzano Group, they are extracting the more and the more in the plants, in a way that for a new plant, they starting from the base with a team that is born with some mindset that will run that plant afterwards. So it means that since the day one, you are talking about these kind of solutions, these kind of technologies, and these technologies, they are not for individual process areas. This started since the first RFQ with a concept which interconnects different areas. So we had several conversations, several discussions, interconnecting the areas, not only talking about this kind of a loop optimization for soot blowing, loop optimization for, no. It's kind of a conversation since day one with this kind of wide optimization. But the first thing, learning from others, and starting a new concept with this kind of philosophy, let's say, in everyone's blood since the day one.
Do you have these traditional teams like maintenance and production and pulp and paper and recovery, or do you have a different kind of organization because the mill is more autonomous and it works in a different way?
It works in the same way in terms of team organization. One thing that is the most is the operator intervention. We are doing the most to make sure that the operator has a smooth operation in the process in a way that he or she can handle the time for make some researches or to work in other topics in a while these actions have been done by the system as well. Basically, the APCs, we are in the phase right now to the mill-wide, to interconnect all the APCs, But from wood handling to the pulp dryer, we have optimization in all the areas. Now we are interconnecting that. So the more the time flies, the more they will face these optimization happens there. It's ongoing at the moment.
Thank you. Mr. Hannu, in order to have also these kind of solutions working with those benefits, which are very striking, I guess you have to optimize very much the instrumentation and the amount of data that you are collecting from the mill. Is Tecnicelpa also helping your clients on this journey to increase this level of instrumentation? And what are the most important information that you have that you need, for instance, on a debarker, which is the one that strikes me the most?
No, usually we want to study what kind of wood handling plant it is in question. Is it a rotating drum or rotary debarker? And we look at whole line from wood loading to the chipper and to the chip pile. And usually it is so that when these raw wood material quality varies a lot, what we find it is that if we compare automatic control, it is these operators, they are not so active than these machine controls. We look at the reference level, how the wood room operates, wood loss, bark content, capacity, and we can make a kind of visit report. And if we don't find good potential to improve efficiency, raw material and energy efficiency, we congratulate and we go to next mill. But once that happens, but not second time. And usually mill persons, they have a very good professional level in instrumentation, automation. So usually it is a good cooperation with them. They don't know these machine vision things and this what we represent, but that's basic things what we know, and cooperation.
Yes, cooperation between you and the teams, and trusting a little bit on the instrumentation that they already have, maybe with some new one that is needed. But it's impressive, the results that you showed here. A question to Marcio also. In order to have this system working, which I think it's a simple system, but it's something that really, as I said, on a general shutdown, it's very hard to get the information that of what's happening around. But it requires also some change on the way people report things. I guess everybody has to be very disciplined in order to give the information for the system, in order for the system to be able to have these kind of reports. What was the process in order to make everybody, a big team, putting the information on the system? Was it difficult? What are the lessons learned that you can bring to us?
Thank you for your question. This system it's simple for using, not complicated. This version simple, and the next version maybe next year we will build a new version with tridimensional mode. This show the recovery boiler. What else? Using artificial intelligence for predictive time of shutdown, general shutdown, and with reports. I mean, yeah, new features. I understand now. No, it's more simple. MKS service for maintenance train about 30 minutes in the system for input data. It's okay. It's not. No, it's simple.
Questões da audiência. Questions from the audience. Anyone? No questions? So last one to André. On a mill that, let's say a brownfield mill that has 30 to 40 years working, as we hope most of our mills in Portugal are, where we can have already a lot of APCs implemented, but we are still on that journey. What would be the time in order to reach something close to Cerrado? What is the way through that these companies have in front of them, and in terms of time spent and effort to reach that point?
Thank you for the question. Excellent touching point. Cerrado was born not with all those technologies that I presented, a couple of them. That's one important thing. The philosophy and the concept for the mill to start, it could be a brownfield or a greenfield, depends how the plant is. You are not going to go to the plant and, okay, we need to replace all the instrumentation to have APCs running to collect this result at the end of 1 year. No. What is the plant? What requires as a minimum instrumentation to achieve this result with these APCs? These kind of studies we have been doing in North America recently for West Rock, for over 20 plants, where we are assessing required instrumentation, basically for implementing such APCs to collect X return on investment at the end of 1 or 2 years. So this kind of plan we are doing. And first we start with this analysis, then we can work with some loop tuning or checking valve signatures, valve conditions, then we implement APCs, then more important than that, this has changed a lot. Instead of delivering the APCs and letting that work, we are concerned to support people in the plant to track its performance, to make sure that this can be running in a daily routine. So people need to understand the APC's behavior, not the logic, but the behavior. So we understand that in 1 year, 2 years, we can implement all the APCs in the plant, working in the loops, replace instrumentation to get with the customer when required, and also some spare time to implement such an advisory and monitoring tools. One more, not necessarily in Andret's case, Andret's application to track that. We are able to support the customer with a Viva system, Microsoft, any other platform to support you to visualize the APC's performance. We have this expertise to support you to embed that. Not only go with Android's applications, we can support you to achieve that. And one more information or comment on that, our APCs are not black box. It means that the users currently, they are able also to implement their own APCs using Android's library. Not necessarily Androids to deploy the APCs. The customer, if intended, we can train in the libraries, like in MATLAB, for instance. You drag and drop the blocks and you implement your own APC. That's one also key change that we are working on. We are interested to make sure that the customer will achieve the result. How we can customize.
Okay, thank you very much to all three. I think it was a very good session. I guess there's no questions on the audience, but if there is one, we still have room for one. Yeah. Okay, so we have one. Mr. Than.
Thank you very much for the presentation. Tan Trung with Fit Voice Company. Question for all of you, actually, with regards to these AI systems and so on. Cybersecurity. This is a major impact associated with this and how much we're interconnected. How are you, as a provider, taking care of this for the mill?
Who wants to start?
In the mosaic I present, there is one box that's named the cybersecurity. 3 years ago, we purchased a company in Israel, which is a cybersecurity provider, now owned by armies. So first thing we do is some assessment in the plant in a way that, okay, we are going to add this system in this part of this topology and what kind of risk analysis we should do together with the customer. This we do for all the cases we implement. On top of that, we are also provider of services for cybersecurity. We have some solutions to detect some faults in advance, some intrusion in the topology, in the automation. We also have some softwares that do this kind of analysis. One of them is named Run Square. Later on, you can check on internet, or we can provide you some details, which do this kind of penetration analysis in the system. So, very nice topic. There is no digitalization services or software without talking about cybersecurity. And when we approach the customer during any risk analysis, that's the first step.
Do you want to add something?
Thank you. That is very important topic. We, at this size of the company, we need to follow our customers' cyber security instructions in our deliveries mainly. But of course, we have in our own company very strict rules for cyber security, and we use the latest tools what there are on the market for these purposes.
So in the system using JWT, SEC, and SSL certificate, CORS, what else? And the cloud of Eldorado Industry, basically.
Just one more comment. It was a very nice question and quite important. What we see currently, people are, and it's fair, people are always afraid about this topic. There is always some blocks to send the data to cloud. And most of the solutions that we see, they are on site, let's say. And it's hard to imagine some systems send reference to the plants from the cloud level. Currently, what we see is maximum, let's send some data for analysis, but not to act in the process, because it's still a pain for all the customer, and that's a fair pain. So I agree with that. We should be conservative, but things are progressing, and what we are trying to do also to surf in this wave, to provide also solutions to make sure that we can progress with safety, of course.
Yeah, it's quite a topic, and it's a very important topic. So thank you very much for your question. I think I can add to that nowadays we are really thinking of how putting things on the cloud that are able to write on our process will be a question for us in the future. It's not easy to understand latency. It's also a problem because we need fast answers, and we don't know exactly what are the answers that are coming from the cloud. So there's a lot of things interesting on that discussion. So thank you very much. I think we already exceeded our time. I think it was a very nice session. Tecnicelpa, of course, is agradeço to all of you for this session, and to all of you that were here on the room. I have a small gift for you before you go, and we will have the next session will be very interesting with our CEOs on the pulp and paper companies of Portugal. So I invite you to go there. Okay, thank you very much.